Chapter 21, page 422, Part 2. Selection of department systems. Many factors must be considered when selecting an information system to support activities used by a specific department or facility. Key issues and requirements must first be evaluated and defined. Before selecting a system, the following questions should be asked and answered. Why is the system needed? What does the system need to do? Is the system capable of doing what is needed? Is the system compatible with existing systems? Issues related to the appropriate range of budget costs and the projected volume of transactions that the system will process are also important. Other concerns may include the types of hardware and operating systems available and the functional needs of the department, including the number of users. Also, if financial or patient-related information is involved, the system must be able to access the data in compliance with industry standards and regulatory requirements. After a system is selected, hardware and software must be installed. Vendor application software can be purchased outright or acquired through a software-based software as service (SaaS) model. Application software installation typically requires initial implementation, support costs, and payment of annual maintenance fees if purchased outright. If software and implementation costs are bundled, their costs may be prorated over time through monthly, quarterly, or annual payment schedules. Significant costs are generally involved in this purchase is typically treated as a capital expenditure even when a subscription-based solution is chosen. Tracking systems for central service. The process and needs of the central service department have changed over the years. Advances in sterilization and instrument technologies and durable medical equipment and supply inventory are ongoing, and costs for instrumentation purchase, repair, and replacement have led to a greater need for improved asset tracking and management. Overview. Tracking systems available for use in the CS can forecast needs and identify processing costs for trays and single instruments. These tracking systems can also help maximize equipment and inventory utilization to provide pertinent information as future budgets are developed. Many healthcare environments still use procedures that, while popular for many years, should now be reevaluated. CS personnel must also move out of their comfort zones as they improve process to maintain patient care equipment for nursing units and track supplies, instrument sets, and trays to use throughout the facilities. Manual methods using handwritten tags, logbooks, wall-mounted bulletin boards, etc. to track equipment are now being replaced with computerized alternatives. Many facilities acquire a turnkey system with limited features or support that generate less than ideal information. A better strategy involves using a reputable product that provides updates to ensure that the facility receives necessary support and upgrades. Definition: turnkey system. A computer system supplied to a customer in such a complete form that it can be put to use immediately. Tracking methods. There are several types of tracking systems and methods available. Examples include use of barcodes to scan an item's last known location and radio frequency identification, RFID tags, used for real-time tracking of patient care equipment. System ease of use, cost, and compatibility with other software systems in use are among the factors affecting purchasing decisions. Additionally, to ensure reliability, the tracking method must be compatible with the processing practices and technologies used by the facility. For example, RFID tags that can be sterilized reliably reliably are relatively new advancement and can be costly. Barcode tracking is generally used for tracking sterile surgical trays and instruments, while RFID-based radio frequency identification tags tracking system, on the other hand, is generally reserved for tracking patient care equipment, as the devices are not subjected to a sterilization process and a cost-efficient, reliable tag can be used. A tracking system may typically be either a traditional installed software application with a database managed by facility information technology, IT personnel, or a web-based application with a database managed, hosted by the software vendor and accessed through the internet. The latter, commonly referred to as cloud computing, may offer several advantages, including cost benefits and ease of installation. Definition: cloud computing. The practice of storing regularly used data on multiple servers that can be accessed through the internet. Integration or interfacing capabilities are of importance when communicating critical information to and from the tracking system. OR scheduling system interfaces are typically desirable to both CS and the OR because they facilitate information about instruments, supplies, and equipment needs based on the surgery schedule in real time or near real time forecasting. Tracking systems meet specific needs. A tracking system must meet the specific needs of the facility that uses it. For example, in a multi-hospital health network, there are many certain modules or special features in the system utilized by personnel at one site, but are not implemented or used at other sites. This is generally due to differences in the complexity of processing or logistics between sites and departments. For example, a processing area supporting small ambulatory surgery department may not have a need for the tracking features that a CS department supporting a large patient inpatient OR would find beneficial. Conversely, the ambulatory surgery area might have a need for features related to flexibility or flexible endoscope processing, which may not be meaningful to a large CS department. In short, a well-developed tracking system has built-in flexibility and scalability that can allow CS departments to tailor the configuration to meet specific needs and also allow for logistical reconfiguration or changes as needed. Computerized systems in use. Computerized methods facilitate more effective data tracking for rapid report generating and are much more comprehensive in scope and efficiency than manual systems. Data integrity is consistently more reliable than with a manual system. Computerized standards are accepted by the Healthcare Information Management Systems Society, HIMSS, and are used by acceptable facility departments to securely store backup data. Definition: Healthcare Information Management Systems Society, HIMSS, a global, cause-based nonprofit organization focused on better health through information technology. More about tracking systems. The continual need to update information is critical for the success of any tracking system, regardless of whether its primary use is for instrument processing, case cart pick lists, preference cards, inventory control, or other purposes. See Figure 2.15. Surgical instrument sets or single-use peel-packed items can be tracked or located at the packaged and sterilized product level using one-dimensional 1D barcode labels. Small RFID tags, which can be used reliably within the sterilization process, can provide real-time location data when they are affixed to instruments or trays. It is likely that RFID technology will coexist with barcodes because they use of a barcode promotes in line of sight inspection by the user when scanning an item. This is an essential step to ensuring the sterile integrity of packaged products. Individual instruments can be tracked or located within a set tray using two-dimensional 2D matrix barcodes. These are marked directly on the instrument using a laser etching or engraving process or through the placement of a dot type matrix label. See figure 21.6. Individual instrument tracking ensures specific instruments are kept with a specific set. It can also locate specific high-cost complex devices such as powered endoscopic or robotic instruments for required prevention maintenance inspection. In facilities where the risk of exposure to emerging pathogens such as Creutzfeldt-Jakob disease or CJD is high, individual instrument tracking is crucial for demonstrating the processing or dispensing actions taken in the investigation of a suspected or confirmed exposure. System documentation and scanning can be done with many different types of devices. These include wireless mobile handheld devices, see figure 2.17. It's a handheld scanner which uses to capture information from an item that is sterilized. These devices are wired directly to the computer terminal. Fixed radio receivers that read RFID transporter signals throughout the facility and manual entry of information into the computer. Those are all examples of system documentation scanning devices. Decisions about system utilization should consider the specific environment to which the items will be exposed. For example, the cleaning and sterilization process for instruments and sets must be evaluated in detail during any implementation planning process to minimize the risk of any adverse impacts on the tracking system. For example, chemical agents designed to be compatible for use with instruments based on the materials used by the manufacturer may negatively impact laser etching, fade barcode labels, and make them unreadable to the scanner after repeated use. Heat generated during steam sterilization may damage RFID tags and may impair their functionality. Water, chemicals, and drying temperatures used to clean case carts and other equipment may cause the adhesive used to affix the RFID tags to dissolve. When this occurs, they can fall off or become damaged with water leakage. As these risks are recognized, manufacturers are generally respond by making improvements to components or process to ensure reliability. Features of instrument and equipment tracking systems. Instrument and equipment tracking systems can provide many different features to assist CS professionals in the facility's OR, finance, nursing, and administrative departments. All tracking systems include some basic operating features. However, more advanced systems include additional features to enhance their usefulness. Basic instrument and equipment tracking systems typically contract or account for the following: complete instrument sets or trays, specific equipment items, last known location of a specific instrument set, tray, or equipment, cost and value of specific equipment and instruments, and the total cost of an instrument set or tray, number of complete processing and use cycles through which instruments and instrument sets have moved, usage of specific equipment, preventative maintenance schedules and repairs made to the specific equipment and instrument sets or trays, Basic instrument and equipment tracking systems also provide other information, including complete tray lists for accurate tray assembly and equipment setup, see figure 2.18, such as name of CS technician who assembled and inspected the set of or equipment, date, set, or equipment when it was processed, sterilization and quick cleaning modality process, catalog number and manufacturer name to identify instruments and associated equipment supplies, quantity, individual and total of instruments included within the set or tray, identification of instruments missing from set. Note that these can be identified on the list that can be affixed to the outside of the set for identification and tracking. Also, productivity reporting information, which takes into account sets and instruments processed and complete during a specific work shift, sets and instruments completed by specific employees. Note, this information is helpful for educational and training purposes, and equipment processed and distributed. Quality assurance data for specific facility-based information such as sterilization load quarantines or recalls, biological monitoring standards and regulations, educational in-service documentation, and then financial data for documenting and managing. It helps with instrument replacement and repair, equipment replacement and repair, preventative maintenance notification, preventative maintenance records, utilization of instrument sets, trays, and equipment, and finally, productivity data and staffing requirements for peak operational workflow. Integrating and interfacing with clinical systems allows facilities to associate or link instrument trays, sets, and equipment to each patient's medical record. Today's tracking system can also interface with sterilization and washer decontamination equipment. Advanced systems. Instrument and equipment tracking systems may also include some advanced features that are beneficial in certain healthcare facility applications. RFID tags enable real-time location of an instrument or equipment item as it moves through the facility and processing cycle. The real-time location of a complete instrument set or tray can also be assessed. Set level tracking features to allow staff members to know the last scan location of an instrument set or tray. And individual instrument level tracking features to allow staff to track a single instrument within a set or tray and identify the set into which a specific instrument was placed. Note, this information represents a generalized list of features that software developers typically provide in their instrument and equipment tracking systems. A complete review of facility-specific needs is required to select the most appropriate tracking system. Conclusion. Central service professionals must responsibly manage the equipment, instruments, and supplies entrusted to them by their healthcare facility. An instrument and equipment tracking system facilitates this goal by capturing pertinent data, logging and document practices, and CS-related functions, and more. As computer technology and information systems continue to evolve, additional capabilities will become available to help facilities better address operational activities and facilitate high-quality patient care. Even so, computers are only one part of a total information system. While computers and tracking systems provide numerous benefits, CS professionals are the key to providing efficient and effective services to help their departments support the facility's core mission, which is providing safe, high-quality patient care and customer service. Terms to remember: turnkey system, cloud computing, Healthcare Information Management Systems Society, or HIMSS. Conclusion of Chapter 21.
Oh my God. Beautiful. Let's go. Let's